I'm Richard Moorcroft, and I'm going to take you on a trip away from Earth, through the planets and all the stars of the universe. We'll start our journey fairly close to home with the solar system. That's what you can see right here. The solar system is made up of our sun, which is over there, and then all of these planets revolving around it. Now, the closest planet to the sun is Mercury. That's right here, pretty small. Then comes Venus, our own Earth, Mars, and then in this belt here, there are some asteroids, which are basically pieces of rock. Then we move into the big ones. This is Jupiter. Behind that, Saturn, Uranus, Neptune, and then finally, furthest away from the sun, way back there and very small, Pluto. But just before we have a look at all of these planets, let's look at the center of the family, the sun.
The sun's so big that 1.4 million Earths could fit inside it. The sun's made of gas, mostly hydrogen and helium. Hydrogen forms helium, providing the heat and light that we receive on Earth. The darker patches here are called sunspots. They're actually the cooler parts of the sun's surface. These giant explosions are solar flares. They're very hot spots on the sun and last no more than a few hours. This solar wind is a high-speed stream of gas given off by the sun, mostly at the time of the flares. On Earth, we see its effect near the poles when the solar wind hits our atmosphere. It's called the aurora.
Now, Mercury here is the closest planet to the sun. In fact, it's so close to the sun that it's hard to observe.
Mercury is only easy to see when it moves away from the sun. In fact, Mercury is 58 million kilometers from the sun, but because distances in space are so vast, it's helpful to measure it in terms of the Earth's distance from the sun. This distance is called an astronomical unit, and Mercury is less than half an astronomical unit from the sun. The first good photos of Mercury were taken in 1974 by the Mariner 10 spacecraft. They showed a planet with very little atmosphere, covered with many meteorite craters like our own moon. These craters were caused by meteors hitting Mercury when the solar system was very young. This was billions of years ago, but the craters are still obvious today.
Now, Mercury wouldn't be a very pleasant place to live. It gets very hot, up to 400 degrees Celsius, and there's very little air. In fact, the only way to live on Mercury would be underground, deep below the surface. Now, the next planet out from the sun is Venus, which is named after the Roman goddess of beauty. It's called the evening star, and it's usually seen soon after sunset.
Venus is the closest planet to the Earth in both size and distance. Venus is very bright because it's covered in clouds which reflect light. It rotates around its axis every 243 days, so a day on Venus is equivalent to about 8 months on Earth. Robot space probes have found that the clouds of Venus are made from sulfuric acid, the same acid used in car batteries. The atmosphere on Venus is mainly carbon dioxide, the major greenhouse gas, and so it's like a super glass house. Heat from the sun gets in, but it can't get back out, so Venus is very hot, more than 500 degrees Celsius.
And the air pressure from this atmosphere is crushing, 90 times that on Earth. It would be a little bit like being at the bottom of the sea. Now, the next planet out is our home planet, Earth.
The Earth is 150 million kilometres from the Sun. And remember, this distance is our astronomical unit.
Life exists here on Earth because of water. Now, plants grew first, and they turned the carbon dioxide in our atmosphere into oxygen. And that's what we humans and all other animals need to breathe.
Earth's atmosphere and water came from volcanic activity. Our planet is the only one in our solar system where a large amount of water exists as a cool liquid. Without it, life could not have started here.
Now, around the Earth, closest to us, as you can just see here, travels the Moon.
The Moon has no atmosphere and no water. Its surface is covered with impact craters. The Apollo 11 mission in July 1969 was the first to land men on the Moon.
Looks like you've been flying well up there, partner. The spacecraft looks good. Tranquility Base here. The Eagle has landed. See you coming down the ladder now.
The visitors found that the low gravity on the Moon meant that they weighed 1/6 of their Earth weight. They could jump around freely.
Hey, who's been tracking up my lunar surface? You're pretty agile there, Twinkle Toes. You bet your life I am.
Craters on the Moon are named after scientists. On Venus, all the surface features are named after women, because Venus is the Roman goddess of beauty. And on Mercury, they're named after writers, painters, and composers.
It's all over. It's boring. Stop over till I see it.
Because the Moon doesn't have any air, the sunlight is very hot, but in the shade, it's extremely cold, over 170 degrees below zero. Many rocks were collected and brought back to Earth for examination. Useful minerals were found. It might be possible to set up a colony on the Moon to operate a mine. The minerals could be used for building stations in space. Future mining operations will use equipment specially modified for low-gravity operations in a vacuum. The Moon has another valuable resource, a type of helium gas known as helium-3. It can be used to supply nuclear power. 1 ton of helium-3 has the same energy as 10 million tons of oil. Space stations could one day be built from minerals brought from the Moon. They could produce solar-generated power and send it to Earth. People could live on the stations for months or perhaps even years.
Now, the next planet, beyond Earth and our Moon, is Mars. And its very fierce red colour led to it being named Mars after the Roman god of war.
The outside planets are known as gas giants. Mars is the last of the inner planets, which, like Earth, are made up mostly of rock.
People imagined that these two moons here were horses driving the god's chariot. And the names of the moons, Deimos and Phobos, mean panic and fear. They're both very small. Phobos is around about 20 kilometres across, and Deimos is only half that size.
Here are the moons going round Mars. Because they're so small, gravity is very weak. If you dropped a rock from your hand on Phobos, it would take 3 minutes to reach your foot. The many channels on Mars have been caused by water or lava from volcanoes. In the past, people thought there might be canals indicating civilized life on Mars. There are huge canyons on Mars. One is almost 10 times the size of America's Grand Canyon. Mars also has several volcanoes. At 25 kilometres, Olympus Mons is 3 times higher than Mount Everest, the highest mountain on Earth. Robots from the Viking spaceships took soil samples from Mars, which were analysed in robot laboratories aboard the craft. But they found no traces of life in the samples tested. Water is frozen on Mars at the poles. Perhaps we could melt it with giant mirrors in space reflecting the sunlight. The ice also contains frozen carbon dioxide. Now, if this was evaporated, it would trap sunlight and warm up the planet. Plants could convert carbon dioxide to oxygen, and people could live there.
Well, perhaps one day people will be able to live on Mars, but they will have to be protected from the cold. Now, as we move beyond Mars, we come to this area here where there are asteroids. Now, the asteroids are very large rocks which travel mainly in this gap between Mars and Jupiter. Some of them are very rich in iron and other minerals which could be very useful to us. And one day we will probably bring some of them back to the planet Earth. Now, past the asteroids is the largest planet in the solar system. That's this one, Jupiter.
Despite its size, Jupiter is no sleeping giant. In fact, it spins so fast that the length of a day is just 10 hours.
Now, like our Sun, it contains hydrogen and helium, and perhaps one day rockets will stop here to take on these gases as fuel for a journey way back to the stars.
The unmanned Voyager mission to Jupiter in 1977 needed the most powerful rockets ever fired. Voyager gave us our first real look at this gas giant and its large moons. So far, more than 50 moons have been found orbiting Jupiter. Some of the smaller ones are asteroids captured by Jupiter's gravitational field. The coloured markings are clouds in the atmosphere, and scientists don't yet know why they are coloured. The red spot is a tropical storm that's been raging for at least 300 years. The Voyager space probe also identified a ring of dust around Jupiter. Passing Io, one of Jupiter's moons, Voyager also identified a number of active volcanoes. These erupt, releasing an enormous amount of sulfur and sulfur dioxide. Callisto, another moon, has a rocky core, but its surface is made mostly of ice.
It would be hard to live on Jupiter. It's just gas and liquid, and the atmospheric pressure is crushing. And the force of the gravity, because the planet is so big, is so great that it would pull you down onto the floor in a puddle, a bit like an egg being squeezed out of its shell.
Now, the next planet, as we move further out, is Saturn. The spectacular thing about Saturn is the giant ring system, observable from Earth, even with a small telescope. Saturn, like Jupiter, is a gas giant composed of hydrogen, helium and other gases. The spacecraft Voyager was sent to have a close look at Saturn's rings. It found them to be an exquisitely thin disk containing dust particles, snowflakes and rocks. It also found that Saturn's rings have kinks and clumps. The rings have patterns, a bit like spokes on a bicycle wheel. The patterns change over time. Voyager crossed through a gap in the rings that had been cleared by one of Saturn's moons. Because it has so many rings, Saturn is sometimes called the Lord of the Rings. Of its 18 moons, Titan is the biggest. Titan's atmosphere is similar to ours millions of years ago. It's made up of nitrogen, methane, and some organic compounds. Scientists believe this could, one day, produce life. Space probes might be sent to Titan in the future to carry out further tests. Another of Saturn's moons, Mimas, has a huge crater that looks something like a giant eye. If the object that made the crater was any bigger, it may well have destroyed the entire moon. The next planet, Uranus, is lying on its side, so it rolls like a ball instead of spinning like a top. It took Voyager 4.5 years to reach Uranus from Saturn, a journey of more than 3 billion kilometers. Uranus has a hazy atmosphere made up of helium, hydrogen, ammonia, and methane. At the poles, day and night would each be 42 years long. Unlike Earth, magnetic north on Uranus is 60 degrees away from its true North Pole. Finding your way around Uranus with a compass would be a challenge. The rings of Uranus are made of dark rocky particles and frozen methane ice and a thin sheet of dust. Because the rings are dark and narrow, Voyager detected them passing a star. Uranus is a long way from the Sun, so it was a little like trying to see coal dust at twilight. Uranus has 15 moons. Most were discovered by the Voyager spacecraft. One of its moons, Miranda, is possibly the strangest object in the solar system. Its surface is a frozen Arctic wilderness and appears to have shattered and then reformed, possibly after colliding with another object. Some of the cliffs are 20 kilometers high, and if you fell from the top of one, it would take 10 minutes to reach the ground. Let's take a closer look at its complex surface. Neptune is named after the god of the sea for its intense blue colour. Neptune has 2 large moons and 6 smaller ones. The large ones are called Triton and Nereid. Neptune's diameter is 4 times the size of Earth. Neptune has ring arcs. These are not complete rings, but only partial rings made up of dust. Like Jupiter, Neptune has a large storm cloud called the Great Dark Spot and a smaller storm called the Scooter. Neptune is the windiest planet in the solar system, with speeds reaching more than 2,000 kilometers an hour. Triton, the largest Neptunian moon, is about the same size as our moon and is the coldest body in the solar system at minus 235 degrees Celsius. As we pass beyond the orbit of Neptune, we come to the place where some comets are found. This is the deep freeze of the solar system. The comets are giant, dirty snowballs, many of them more than 100 kilometers in diameter. We're about 40 astronomical units from the Sun, in a zone called the Kuiper Belt.
Now, the very last planet in our solar system is Pluto.
Pluto's orbit wanders, so its distance from the Sun changes during the year. Sometimes its orbit is inside Neptune's. Pluto's surface is covered with frozen methane gas. It's not a very large planet at all, about 1/5 the diameter of our Earth.
And it's such a long way from the Sun over there that it was only identified in 1930.
Beyond Pluto, we also find more comets, about 100 million of them, but only a few will ever visit our part of the solar system. From Earth, we see them as giant streaks. They were often regarded as messengers from heaven. The star that led the wise men to the birth of Christ may have been a comet. In the past, many thought comets a warning of doom. Astronomers have found that about half of the comets return many years later. This animation shows that they travel around the Sun in an elliptical orbit. That's an oval-shaped one, a bit like a football. The other half of the comets come from outside the solar system, visitors from outer space. They come towards the Sun, swing around it quickly, then go back into space, never to return. If their orbit is 200 years or less, they come from the Kuiper belt. However, if their orbits are longer than 200 years, they come from the Oort cloud. The Oort cloud is spherical, completely surrounding the solar system, and may extend far into interstellar space. When they're way out here, they're completely frozen and have no tail. As the comet approaches the Sun, the ice evaporates into gas. The solar wind from the Sun pushes dust and evaporating gas away from the comet's core into a long tail. The comet's tail gets longer and longer and is lit up by the Sun. The tail can sometimes be 20 million kilometers long. As the comet goes around the Sun, the tail changes direction, always pointing away from the Sun. Occasionally, a comet actually hits a planet. In 1994, fragments of the comet Shoemaker-Levy 9 collided with the gas giant Jupiter. As each fragment hit the planet at 60 kilometers a second, it released energy equivalent to 100,000 nuclear bombs. The exact composition of comets remains a mystery. Scientists are planning to use space probes to find out more.
And with the comets, we come to the very edge of our solar system. But how was it created in the first place? Well, let's have an action replay.
Our whole solar system was made out of a giant cloud of gas and dust. At first, it was very cold, but as it collapsed, it became warm and then hot. Eventually, the center became hot enough to switch on the hydrogen. A disk of gas and dust was left behind. The planets formed out of this material. The third from the Sun is our home, the Earth, where conditions were ideal to nurture life.
Now, the solar system is enormous, but really it's only a very minute part of the whole universe. And the universe consists of all the stars that we think exist.
We live in a galaxy called the Milky Way. In the whole universe, there are probably 100 billion galaxies. Most galaxies have about 100 billion stars.
Ever since early times, the stars have always fascinated people. But when we learn about their numbers and their size, we begin to feel very small. But one day, we'll probably send out expeditions to explore and perhaps even settle some of them, just as people on Earth sailed off to settle distant lands.